All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be learning about Ratatouille, which is a TUI framework for Rust. In the past, we have looked into Ratatouille. I do remember doing a couple of streams surrounding Ratatouille. I don't remember how far into the tutorial we got, or if we even started the tutorial on stream. Maybe I just spent time reading up on Ratatouille, and we never really got to the part where we actually learn Ratatouille. That's also very much a possibility. Where was I going with this? Yeah, I forgot where I was going with this, but oh yeah, I was saying that I don't remember if we have actually done any streams where we properly explore Ratatouille. Dude, the more deeper I'm getting into the Rust ecosystem, the more excited I'm getting to try out a bunch of different things. Something that I do have planned for the future, actually, I need to write this down. Yesterday, unfortunately, I had a bit of a out of memory issue on my machine where my Tmux sessions are hosted. I had a Twitch VOD that was playing somebody else's VOD, and they had copyrighted music in various segments. And Twitch Twitch mutes those segments of the VOD where copyrighted music is found. And there's this weird issue where sometimes, so first of all, like there's this weird issue where the player will kind of freeze in those sections, or it'll start to buffer, or there'll be some kind of like interruption, some kind of hitch. You won't have like a proper seamless viewing experience. But there are also times where that little hitch, for some reason, results in high CPU or high memory usage. I have no idea what's going on there, but like whatever that is, it seems to be glitchy. There's some sort of issue going on there. Well, anyways, I had this person's VOD playing, and I went to sleep having the thing open because I was actually expecting to wake up and then stream. It was supposed to be a short nap, but then prior to that, I hadn't really slept for 24 hours. I was planning on taking a short nap and then waking up and then streaming and then going to sleep, but then I just ended up going to sleep, and yeah. But then when I woke up, I noticed that the machine on which I have all of my Tmux sessions hosted, it was it was on the login screen, and that usually never happens unless some major crash has happened. And I'm kind of glad that it was. So okay, what ended up happening was I'm pretty sure it was that Twitch VOD that ended up causing the either the CPU or the memory spike. And usually when there's a memory spike, then Ubuntu is going to try its best to kill a bunch of processes, just to save the memory, just to save the entire system from rebooting. And I'm kind of glad that it did that, because what it ended up doing is it crashed a bunch of the. First of all, it crashed Firefox. I'm pretty sure it went. The first thing that it aimed for was the thing that was using the most memory, and then it went, down the down the ladder, finding more and more processes to kill. So I'm sure it found the Rust analyzer and the NeoVim instance that had the Rust analyzer launched, and there was a bunch of Gemini CLI instances. So it closed all of that stuff. The good news is that it didn't reboot the system, so my Tmux sessions were all safe. Uh, I did have to reopen Gemini CLI, and I kind of had to spend some time going and searching for the directories in which I had launched a couple of conversations. The good news with that is that it did make me explore Gemini CLI more. And one of the things that I learned about Gemini CLI that I didn't know before was that aside from the chat saving system that it has, which is it's a system where you can save a checkpoint at any point in the conversation. Well, at the current point in the conversation, you can save a checkpoint, and then at any point later on, you can load that checkpoint. And the checkpoints are usually saved per directory. And there's also another, aside from the checkpoints, there's another feature called resume, in which you can resume some of the previous conversations that you started within that specific directory. So in a way, it's kind of like saving, but like you are not saving that. That's just like it's just like a copy that's maintained by Gemini CLI itself. And I'm fortunate enough that that copy was there, or those copies were there, because there were a bunch of conversations that I was having that I had open, which I would have lost if I wasn't able to use resume. Anyways, I don't remember why I was talking about this. Yeah, I don't remember where I was going with this. But yeah, okay. So I'm excited, dude. Soon what I want to do is at some point I do want to explore the M Lua crate, which allows you to bring sorry, zoned out. Okay. At some point I do want to explore the M Lua crate, which allows you to um, it allows you to run Lua code within your Rust program. So you can interact with Lua in various ways. You can run entire Lua code. You can call Lua functions. You can also set up Rust functions that your Lua code will call. So like if certain functions are called within Lua, then those functions could then call Rust functions, or you could set up some kind of like callback mechanism. And there's a lot that you can do. Basically, you can embed Lua into your Rust program using this crate. And the first place that I plan on doing that in a more serious capacity is in my own VTuber app that I'm going to be working on in Rust. So I'm excited for this because this is going to allow me to build a system that can be scripted, and I don't always need to change the Rust code, and then recompile the program. I can just build a programmable system and then program it using Lua instead of having to recode the functionality each time, and then, or well, code the functionality in Rust each time and then recompile the program. All right, so today we're going to be looking into Ratatouille. Give me a second. Let me just unmute this stream that I have playing in the background for some background noise. And then we can get started. Okay, so we are in the tutorial section. I have a Rust project. I have a Rust project set up for Ratatouille, and we're going to take a look at some of these tutorials and get started with Ratatouille. So first we have the hello tutorial. Okay, let's start reading this. I think I need to zoom in just so I can read a bit better. And given this weird layout, now I have to zoom in way too much. Yeah, I think that's way way too much. The problem with these kinds of layouts is, especially when I try to like zoom in, now you'll notice the menu is taking up so much of the space which could have been used by the text. This sidebar is now taking up a whole lot of space that could instead have been used by the text. And I don't know if there's a way to close this. Is there a way? Uh, or maybe even like a some kind of resizing option. I don't think so. And usually if that's the case, then I end up having to, keep zooming in until it's just the text taking up space. Yeah, I think you know what? Okay. We could okay, whatever, dude. Let's just start reading. Okay, this tutorial will lead you through creating a simple Hello World TUI app that displays some text in the middle of the screen and waits for the user to press any key to exit. Okay. It demonstrates the task that any application developed with Ratatouille needs to undertake. We assume that you have basic understanding of the terminal and have a text editor or IDE. If you don't have a preference, VS Code with Rust Analyzer makes a good default choice. Okay, prerequisites. Install Rust. Okay, okay. Install Cargo Generate. I think I do have Cargo Generate. Hold on. Let me... Um, Cargo... Yeah, I do have Cargo Generate. In fact, I think I have Cargo Generate for a couple of different things, including for ESP32, because ESP32 also requires certain um, a very specific type of build. Even within the cargo toml file, you have to mention specific settings. Um, there's specific, I believe there's specific boilerplate code as well. I can't remember, but yeah, okay. Install Cargo Generate. Ratatouille has a few templates that make it easy to get started with a new project. Cargo Generate is a developer tool to help you get up and running quickly with a new Rust project by leveraging a pre-existing Git repo as a template. We will use it to create a new Ratatouille project. Install so and so. Okay. All right. Create a new project. Cargo Generate so and so, so and so. Um, okay. Well, the thing is, I already wait, did they say to create the directory? Let's create a new project. Okay, navigate to a folder where you will store your projects and run the following command. Can I hold on? What are the flags that I can provide to Cargo Generate? Let me take a look at that, because I needed to be like an init sort of situation, like how I'm able to do cargo init. I want it to be that kind of situation. Um, Print this help message. Okay. Oh, okay. Generate. There it is. D, define a value for use during so and so. Define so and so, so and so, so and so. Okay, in it, generate a template directly into the current directory. No subfolder will be created. That's what I'm looking for. That is what I'm looking for. Do I need to specify D though? Here? No. Okay, these are okay, okay. All right. For some reason, okay. So I was thinking that it's like D is a separate thing, and then all of the things on the right side of D are something that come under D. But no, that D was just for define, just like how The A is for allow commands, O is for overflow, stuff like that. Okay, so I can just specify init the way I specify what do you call it? The way I do cargo init to create a Rust project within this current directory. Same way I can do it for that. Okay. Back up. If I just do cargo and generate here, does that also lead to the same thing? Okay, we have cargo and generate. And what if I do cargo gen? So are these two different tools? I can't remember like which one. Okay, this one gives the version, doesn't it? I don't remember. Um, oh, it says usage cargo command generate. Okay, cargo generate. Yeah. Okay. All right. If I do which cargo generate, let's see. So that's launching that. Then maybe internally this might be calling cargo along with generate. Is it? I'm not sure. I'm not sure. Anyways, cargo generate. Do I still need to do? Well, no, it's saying that here, right? It says cargo make me a pro. All right, okay. The usage says cargo, and then command can be generate, in which case it does exactly that. Okay. What was the usage for cargo generate? Okay, template selection, git or path. So there's there's information missing here, but I'm glad that I'm looking it up. Or I mean, hold up. What if it's like positional by default? Yeah, there it is. Okay, so options, and then we have auto path. Does template selection come under that? I don't know. Attempt to use either git or favorite if either is specified explicitly, and then subfolder. Specifies a subfolder within a template repository to to be used as the actual template. So the path. Oh, okay, okay. That's why we do git. Did it mention git here? It's not mentioning git here. However, it does do auto path. I'm guessing git might be like the default. I'm not sure. Let's see if it mentions here template git repo to clone. Does it mention that this is the default selection? Well, it's okay. Doesn't matter. Um, auto attempt to use as either git or so and so. Oh, if either is specified explicitly, use as subfolder. Okay, maybe that's why they didn't bother specifying over here. It's probably because there's like a default behavior kind of, built into this, so you don't need to worry about it too much. Now, the first thing I need to do here is delete all of this. What was the thing to select all? Um, toggle all, Control A. All right, there. So let's delete this, and then we'll do cargo generate. Did I spell that wrong? Generate, yeah. Cargo generate Ratatui slash templates. Hold up, something looks odd there. Ratatouille slash templates. For some reason, the rendering got a bit weird there. And then simple. not found in config, using as a git repo. And Ratatouille is spelled wrong. Yep, that little rendering issue caused this confusion. Okay, cool. Uh, Good thing that they are asking for the name, so we can give a custom name. Short description. I don't know, first uh, Ratatouille proj. All right. The thing is oh, wait. Back up. I made a mistake here. I just made a mistake. I had this, I had NeoVim open here, and then I did all that. You know what? Okay, we have this thing. Uh, let's also build it. Couldn't find, oh God. It created the thing as a subfolder, didn't it? Yes, it did. So we're going to get rid of that, and we're going to rebuild the project. And I don't remember where the options are supposed to go, so let's do it in this way. Yeah, Ratatouille proj 01. First, Ratatouille proj. That's done. Great. Now, yeah, there it is. Now we can do cargo build. Give that some time to build. And in the meantime, oh, actually, wait, I just remembered I need to open up my chat on my phone. Oh. Had one of Iron Mouse's clips playing because I had TikTok open. Okay. Stream Manager. And open up the chat. All right, great. And this is done as well. Awesome. Let's try running this and see what... There it is. This is our simple hello world template. So now we're going to open this up in NeoVim and take a look at the code. Let's see what this says. Right, so create a new project. Let's create a new Rust project. In the terminal, navigate to a folder where you will store your projects and run the following command to generate a new app using the simple Ratatouille template. You can find more information about this template and so and so. All right. Okay, you'll be prompted for a project name to use. Enter so and so. All right, that's fine. Examine the project. The cargo generate command creates a new folder called Hello Ratatouille with a basic binary application in it. If you examine the folders and files created, this will look like so and so. All right. So this is our code. There's a whole bunch of code that we need to, oh God. Okay. Holy shit. Yeah, we have quite a bit to explore here. Okay, the cargo Thomas file is filled with some default values and necessary dependencies of so and so. All right. Okay. Oh wait, there was also color I mentioned. Color ire, I think. Color ire. Yeah, I think that's how it's spelled, and or well, that's how it's pronounced. Anyways, I think I need to install Color Eye. I don't remember. Or well, no, I did do the, what do you call it? Yeah, if I because I did the template thing, so it probably was included in the Toml file. Yes, there it is. So once I did the cargo build thing, it downloaded whatever was necessary and then installed it as well. Well, not installed, but like built it in as well. Okay, the generate command creates a default main.rs app, and this is what it looks like. Okay, this is our code. Okay, before Ratatouille so-and-so, the setup of an app was quite a bit more complex. Older Ratatouille apps may have code that includes a lot of boilerplate code to set up the app. The latest version of Ratatouille has simplified this process to just calling ratatouille.init and ratatouille.restore. Okay, so this is our main function. Okay, restores the terminal to its original state. This function should be called before the program exits to ensure that the terminal has restored to its original state. This function will attempt to restore the terminal to its original state by performing the following steps. Raw mode is disabled, and the alternate screen buffer is left. If either of those fail, the error is printed to standard error and ignored. Use this function over try restore when you don't need to handle the error yourself, as ignoring the error is generally the correct behavior when cleaning up before exiting. If you need to handle the error yourself, use try restore instead. All right. Okay. Right. So we run the app, and after we run it, we get to see this. Cool. Great. You can press any key to exit and go back to your terminal as it was before. See, I was expecting them to like dissect this code, but I'm guessing they're gonna go into it in in a different section. All right. Summary. Congratulations, you have written a Hello World terminal user interface with Ratatouille. The next sections will go more into detail about how Ratatouille works. The next tutorial, Counter App, introduces some more interactivity and a more robust approach to arranging your application code. Awesome. Let's get into it. Okay, the previous Hello Ratatouille tutorial introduced how to create a simple TUI that that displayed some text and waited for the user to press a key. This tutorial will cover how to handle state and some more complex interactions. We will build a counter application that allows the user to increment and decrement a value on the screen. When you're finished, the application will look like the following. Okay. All right. The application will render the counter in a paragraph widget. When the user presses the left or the left and right arrow keys, the application will increment and decrement the value of the counter. Awesome. Okay, a full copy of the code for this page is available in the GitHub repo at so and so. Okay, let's open that up just so we can look at it. Um, and here, I guess we are not using templates. Here we are doing everything from scratch. Okay, cool. So we're going to close this, go back. Okay, Ratatouille counter app. Let's add O1. And then um, where else do I need to change it? Here. Wait. Oh, okay. This is where I need to do it. Um, yeah, cargo in it. Then add the Ratatouille and cross-term crates. See backends for more info. All right, so cargo, add Ratatouille and cross-term. Okay, cargo build. All right, the cargo terminal will now have the following dependencies, the following in the dependencies section. All right, application setup, main imports. In main RS, add the following imports for Ratatouille and crossterm. These will be used later in the tutorial. In the tutorials, we generally use wildcard imports to simplify the code, but you're welcome to use explicit imports if that's your preferred style. Great. So open this up, and here we want to import first stdio. Oh, let's wait for a bit until IntelliSense kicks in, which should be soon. Actually, in the meantime, I could just start typing it out. It's not a big deal. Oh, okay. We are good. Okay, use cross term event. Event seems to be missing. Oh no, event is there. Okay. Event. And then here we do self event key code. Key event and key event kind. Okay, then use Ratatouille buffer layout rect style stylize symbols border text line text, then widgets block paragraph widget, and then default terminal and frame. Okay, cool. Right, some editors remove unused imports automatically. So if you run into errors about missing types, okay, that's fine. Right. So I don't have those issues, but some issues that I will have are, for example, if I type, so they mentioned stylize here, and that cross term has its own stylize. So I might have an issue like this where I'll notice three different stylize options, and I'll think all three of them. I won't pay attention to what's in the within the parentheses. Now, if you do pay attention to it, then you'll notice that one is from cross term style stylize, the other is Ratatouille cross term style stylize. So what I'm supposed to be going for is um, just stylize, I believe, which is what I did here. Yeah, stylize. That's the one I'm supposed to be going for. So I need to be careful of that. But other than that, I think we are good. Okay, main function. A common pattern form found. A common pattern found in most Ratatouille apps is that they initialize the terminal, run the application in a loop until the user exits the app, and restore the terminal back to its original state. The main function sets up the terminal by calling Ratatouille init and Ratatouille restore methods, and then creates and runs the app defined later. Oh, and then creates and runs the app, which is defined later. It it differs. Um, it differs propagating the return of app runs result until after the terminal is until words until after the terminal is restored to ensure that any error results will be displayed to the user after the application exits. Okay, fill out the main function. Okay, let's do that. So let mute voice crack, dude. Holy shit. Let mute terminal Ratatouille init. Let, not let, let app result equals app default. Hold on. Why do we not have app default? Do we have app to begin with? We don't. We don't have app. That seems to be missing. Hold on. There's something wrong here. Okay. Let app result. That's odd. Okay, hold on. Let's also make this change. We have to make sure that the thing returns a result. Yeah, this is confusing. We do not have, uh, we do not have app. It differs propagating the return of app so and so. Did I miss something here? Maybe I missed like a line or something. App is not being imported from anywhere. Oh, could it be under default terminal? No. Where exactly is this? Am I missing something here? I think I might be missing something. Okay, let's type it out and see if IntelliSense gives something. Uh, dot run. Okay. Mute terminal. Now, if I save this, yeah, we have an issue. We also have an issue here. Am I missing something? Hold on. Let me take a look at this code. Just a second. This is the basic counter app. Okay, yeah, we are in that. Okay, so we go to source, look at main. Oh, wait a minute. Okay, hold up. It says pub struct. Is app being defined here? Fuck me, dude. Okay, all right. Okay. Yeah, I've had this exact same thing happen in another situation. I believe it was in Nano. Um, I I think it was. I think it was in Nano. Yeah. Anyways, okay. It makes sense that it's not working. It'll work eventually once I've created the app struct. Then it'll work. We can move to the next line and say Ratatouille restore, and finally we want to return app result. Okay. Then, application state. The counter app needs to store a small amount of state, a counter, and a flag to indicate that the application should exit. The counter will be an 8-bit unsigned int, and the exit flag can be a simple bool. Applications that have more than one main state or mode might instead use an enum to represent this flag. Okay, awesome. So we'll create this, derive, debug, and default. I need to look into implementing default. Yeah, I need to look into implementing default because I'm guessing. Actually, yeah, I don't know. Hold on. Where is this pulling, and why do I need to specify pub struct? I'm curious about that bit as well. Like why the pub part? Okay, counter u8, then exit is a boolean. So we save method run not found for this struct. Yep. Okay, calling app default will create an app initialized with counter set to 0 and exit set to false. Okay, application main loop. For no, most apps have a main loop that runs until the user chooses to exit. Each iteration of the loop draws a single frame by calling terminal.draw and then updates the state of the app. Create an impl block for the app with a new run method that will act as the application's main loop. All right, impl app, and here let's see if it gives us suggestions. Yeah, I'm not sure it's giving suggestions. Well, that's fine. Okay, run, mute self, terminal, mute default terminal, and we want to return an IO result. Okay, then while not self dot exit, then terminal. Which terminal am I supposed to be using here? I need to know that as well. Actually, I did mention terminal in here. So like, which terminal would this be using then? Hold on. Yeah, I'm a little confused here. Um, Ratatouille cross-term terminal. Uh, okay, let's go with this, I guess. Terminal dot draw. This does not have a draw method, and I think we might have also added this thing up here, an extra thing that wasn't needed. Just a second. Let's save that. Oh, it's still remaining like that. Okay, what was our thing here? Cross-term event. Okay, okay. Wait, yeah, no, I'm kind of confused about. Okay, that's crazy. Now it's working. That's confusing. Anyways, um, right, terminal. You're joking. Wait, wait, wait. Self.draw, handle events. Displaying the application. Okay. To test how Ratatouille will display the widget when render is called, you can render the app to a buffer in a test. I've never actually used the testing features available in Rust, the sort of unit test kind of features. And just in general, I've never really explored unit tests. So it's kind of cool that in Rust it's just kind of available already. And if you want to, then you can, you know, create tests and run them. I've been meaning to get into doing tests as well, because I know it's going to be useful for something in the future. In fact, I might need to create tests for some of my own more complex projects. But yeah, for now I need to get this thing to run. We can keep the test aside, and sorry, give me a second. I'm yawning like crazy for some reason. Give me a second. Let me drink some water and also take like a big sip of my energy drink. Okay. All right. Hold on. I like that there's a to-do function, a to-do macro, I guess. Indicates unfinished code. This can be useful if you're prototyping and just want a placeholder to let your code pass type analysis. The difference between unimplemented and to do is that while to do conveys an intent of implementing implementing the functionality later, and the message is not yet implemented, unimplemented makes no such claims. Its message is not implemented. Also, some IDEs will mark to-dos. Oh yeah, mine does. I don't know if it does it in this specific format, but it does do it for, I believe, in this. Wait. Um, Give me a second. I forgot which. Oh, hold on. My thing seems to be stuck. Uh, yeah. Okay. Control R. Okay. We are good now. Yeah. There. That's what I was talking about. So it does mark to do. I forgot which plugin it was that's doing this. Maybe it's Trouble, maybe it's something else. There's also um, I forgot how you get to it, but there's also a thing. Hold on, not window. Oh, actually, I could do it this way. Trouble to do. It might be trouble then. Yeah, it might be. There were two. There were two different ways of doing it. Not just trouble. Trouble is one of them. You access it through X. Is X listed here? X is for diagnostics. Okay. Okay. So bring this back, and then right. Wait, I forgot what does diagnostics give you? Overall diagnostics. Okay. All right. Code related stuff. Um, Wait, do we not close this? Um, Wait, I'm confused as to why this is not closing. Now it's working? What's going on here? That is so odd, dude. Yeah, when this happens, then all of a sudden you can't do anything with that. That's kind of odd. Okay, let's try going to the next. Okay. So this way we can actually do it, and then we can also close. Okay. All right. Uh, quick fix to do. Yeah. So this brings up this, and there was also another way to do it. What was it? Was it under N notification? Not notification. There was another one, dude. I can't remember what it was, but it was a thing that brings up a window exactly like this, to show you the various to-dos and stuff. And like if you had a Python project open with a bunch of what do you call it? With like a bunch of, different packages added as dependencies, it would also list all of their to-dos, all of their fix me's, all of their, errors or whatever else. I forgot exactly what was it? It was something with N. Or maybe I'm remembering notification. What was it? Um, I like that it has a whole list over here for convenience, because otherwise I would have to look at other, like each Many of these are grouped into different sections within the which key uh, within the which key menu. But yeah, okay. Close this. I'm trying to remember where it was from. And do I even have it enabled here? Because there was a certain other. Hold on, I'm gonna open up NeoVim on my other machine and see if it might have been the other machine instead. Just a second. Okay, open up NeoVim, open a new file. Here, X. So we have to do from trouble, then to do fix me, and so on so from trouble. Um, it's not C. Could it be D? Yeah, I can't remember. Okay. All right. Just a second. Let's come back here and continue. Okay. All right. Let's get back to this. Okay, terminal. So I'm still confused about this part, but we're gonna just go along with it. Frame self dot draw frame. All right, then self dot handle. I'm still confused about like why why this terminal that I defined is not being used in here, because it's supposed to, yeah, it's supposed to be used here. We also specified a type. Oh, we are getting an error here. Hold on. Is this the reason? All right, hold up. We are gonna delete both of these. So this is supposed to return a result. So that's why it's complaining. Let's add the result first. So it'll be satisfied. And then let's add, okay, variables in the condition are not mutated in the loop. What's the error exactly? Variables in the condition are not mutated in the loop body. This may lead to an infinite. Oh, it never exits. Um, yeah, to an infinite or to a newer, to a never running loop. Okay, all right. Then terminal dot. Now it's working. That's crazy. It was mainly this. It was one colon that was missing. That's insane, dude. Okay, so now here we provide a closure. Within the closure, frame self dot draw. Um, oh, it's because I haven't implemented draw yet. That's okay. frame and this. Then we do self dot handle. This is also not, oh, that's because, yeah, even that I haven't implemented those two functions. You know what? Let's do that. Let's first implement these functions. Function draw. Why was n there? Oh, fn. Yeah. Function draw. You know what? Let's do it like this. Draw. And then in here, we do add self, frame, mutable reference of type frame. To do. And then handle events, mute, self, and return result. This one is also to do. Great. Awesome. So now over here, when I do self, there's handle events, and our code is, well, almost done. Displaying the application. Render a frame. To render the UI, an application calls terminal draw with a closure that accepts a frame. The most important method on frame is render widget, which renders any type that implements the widget traits such as paragraph, list, etc. We will implement the widget trait for the app struct so that the code related to rendering is organized in a single place. This allows us to call frame render widget with the app in the closure. But hold on. This allows us to call frame render widget with the app in the closure passed to terminal draw. Okay, first add a new impl widget for so and so. Wait, that's interesting. Hold up. I didn't know you could do this. I didn't know you could implement methods separately for how do I even say this? For like for reference versus, or for a borrowed version, or for that owned version. Yeah, I guess that's the best way to put it. In this case, widget for borrowed app. So this is only going to apply in instances where app has been borrowed, not where it's owned. Wait, that's crazy. Hold on. Does this have like its own? Where is this coming from? I'm curious about this. Is this from um, Ratatouille itself, or is it from the, or is this from Rust? Like whatever system is doing the IntelliSense stuff. Okay, they do have the render method mentioned here, so we could probably use this, I think. Yeah, it's the exact same, right? Yeah, function render. The where part, I don't think I need to add that. Just a second. Okay, right. So in here, I need to create a title variable, line from counter app tutorial dot bold. Now let's see what does line actually do. A line of text consisting of one or more spans. Okay, I'm guessing what we added here is a span. This, yeah, I think so. Oh, wait, hold on. We are using from. Yeah, so this is a span. Converts to this type from the input type. Okay, lines are used wherever text is displayed. Words, holy shit. Lines are used wherever text is displayed in the terminal and represent a single line of text. When a line is rendered, it is rendered as a single line of text with each span being rendered in order, left to right. Any new line in the content, any new lines in the content are removed when creating a line using, hold on, I need to, there, using the constructor or conversion methods. Constructor methods. Okay, and then conversion methods creates a line from a string, creates a line from, I forgot what that kind of string is called. Oh, actually, we just used this. Just now we used this. I think it's called a string slice. While an this is an owned string type. This thing is on the this thing is stored usually on the heap, whereas this string is going to be stored in the binary, and then it gets loaded, I believe, onto the stack. I don't think it gets loaded on the heap. I could be wrong. I'm going to have to look up where. But yeah, the second string, the string slice type, this does get stored in the binary itself. Then we can also create from vectors and create from single span. Okay. String from converts a line into a string. Okay. All right. Cool. Great. So that's one line. Next line is instructions. Okay. Let instructions equals line from, and then here we specify a vector. Okay, decrement dot into, and then left dot blue dot into. No, that's not into, that's bold. We need to do this. Yeah. All right. So here we want to do increment, and this is supposed to be right. Right. Quit. This is Q. Okay. All right. That's done. Then, oh God, there's more. Okay. All right. Let block equals block bordered dot title title dot centered, then title dot bottom, oh, title underscore bottom, instructions dot centered. That's interesting. Okay, instructions dot centered. Wait, why are there extra parentheses there? Okay. Um dot border set border thick. Done. All right. Next, let counter text equals text from vec line from vec. Oh, that's why it was up there. Hold up. Yeah. All right. And then here. Okay. Value dot into and self dot counter dot to string dot yellow. Whew, we are almost at the end. Paragraph new counter text dot centered dot block block dot render area and buff. Okay, great, awesome. So those have already been defined. Have they? Hold on. Oh, area and buff is already defined. Yeah. Okay, so we have an issue over here. Text from vec. Okay, where's the issue arising? Dot into. Okay, the trait bound. Oh, backup. Which uh I remember. Hold on. The trait bound so and so. Oh God, these are so long to read, dude. Is not satisfied. Required for so and so to implement cross term style styled. Is it? Hold on. Let's go up here. Yeah, for some reason style.stylize got included here. Yeah, let's try that. Let's try that again. Hold on, where's the error? Where's the error gone? Where was I? Oh, here. Yeah, okay. The error is gone. That was the error. I'm glad that they mentioned this thing over here that um yeah, some editors remove unused imports. So if you run into so and so, then yeah, check that. In my case, I did mention that one issue that I will run into, which in this case happened without me even realizing, is that um, sometimes multiple types tend to have the same function implemented, and um, the I guess it's the linter that's doing this, or I guess it's the linter. Whatever's handling the IntelliSense is gonna, or the code completion system is gonna, it's gonna tell you that there's these three or four same names, but each of them, here's the path that leads to them, and that's how you know that this specific thing that you're trying to access is from that path. Like that's the path that leads to it. So what happens is if you select one that for which the using statement has not already been uh, entered at the top, then it'll be entered for you. I should look into. Yeah, I'm curious about this because like when I'm saying this, then I don't know what I'm supposed to be saying. Is it the Rust analyzer or is it Clippy or something else? Hold on. Um, okay, I'm doing Rust coding in NeoVim. Uh, Let me also mention that it's LazyVim just in case if it makes a difference. I've noticed two things running while I'm doing Rust coding: Rust Analyzer and Clippy. I'm confused as to which one is the linter and which one is the formatter. Also, which one is responsible for code completion. And there was one more thing. Oh, and in this case, is the linter actually? Oh, the LSP. That's what I was looking for. It's the LSP that's responsible for the code completion stuff. Yeah. Um, in this case, which one is operating as the language or as the LSP? Also, isn't it mainly the LSP that does the code suggestions? Okay, it's common to feel confused by the overlap, but in the Rust ecosystem, these tools have very specific complementary roles. Yeah, actually, I definitely have reason to be a little bit confused sometimes with the overlap because there are times where multiple tools will be in used and each of them specializes in certain things, but then sometimes their functionality kind of overlaps. And I've definitely had that situation with Python coding when using both Pyrite and Rough. One of them is a linter, one of them is a formatter, but one of them also does uh, a bit of the linting as well. So it's then kind of like when you're describing that, okay, this is the linter, that is a formatter, then are you supposed to include the other thing as well or what? Okay. Uh, in your Lazy Vim setup, they are working together to give you that IDE feel. Great. Here's a breakdown of who does what. The LSP, which is Rust Analyzer. Okay, Rust Analyzer is the LSP. When you ask, isn't it mainly the LSP that does the code suggestions? You are absolutely correct. The role, it acts as the brain of your editor. It understands the structure of your code, your types, and your crate dependencies. Responsibilities: code completion slash suggestions. It provides the list of methods and variables you see when you type. navigation, go to definition, and so on. So inlay hints, those little gray text labels showing oh, that's the LSP as well. Okay, those little gray text labels showing types and parameter names. Then refactoring. Okay, yep, true, true. The linter, Clippy. Clippy is the linter, while the Rust compiler, Rust C, catches errors. Oh yeah, okay. The linter is supposed to. I keep forgetting this because I don't look at these definitions very often, so I keep forgetting what certain things do. Um, and yeah, the linter looks at. There's two things that it does. I mean, there's probably multiple things that it does, but it does two things. One of the things is catching errors to what extent it's able to, and but here's the thing, right? I believe the Rust analyzer also does that to a certain extent because Rust seems to be very good at catching a bunch of different possible errors that could pop up. Um, that's why like you would have to try really hard to, you know, do something that would really break stuff because the Rust analyzer usually catches a bunch of the stuff that could go wrong and it'll bug you about it like before you can even compile the program properly. Okay. While the Rust analyzer no, while the Rust compiler, Rust C, catches errors that would break your code, Clippy catches code smells. Role, it looks for anti-patterns, non-idiomatic code. This is the second thing that I was talking about. So on one hand, they'll look for like errors, possible errors that could occur, which I believe comes under static analysis because it's not running the code. Um, Though, okay, this thing that it's talking about, like anti-pattern, non-idiomatic code, potential performance issues. Okay, performance issues, yeah, but anti-patterns and non-idiomatic code, I I'm wondering if to a certain extent that comes under formatting instead of linting. But like I said, like these definitions, I don't really look at them as often to actually remember that hey, this thing does that, that thing does that. Another reason for this is that there's often times where tools that are being used, their functionalities kind of overlap in that their functionalities kind of cover multiple bases, not just one. Anyways, Clippy catches code smells. Okay. That are technically valid. Okay, yeah, it looks for anti-patterns, non-idiomatic code, or potential performance issues that are technically valid Rust code, but could be written better. Sorry, zoned out. Okay. Integration in lazy vim, the Rust analyzer. Oh, the formatter is Rust FMT. That's what Rust FMT does. Okay, I've seen that before, but it never occurred to me that this could be the formatter. And the formatting in this case is something like, hold on, what can I use as an example? Where's my main function? The main function is here. Uh, would this even work in this case? I'm not sure. Hold on. Let's do vec. Um, let a equals this. Oh, this is probably going to throw an error. It might throw an error, but for now we can just, okay, so 1, 2, 3, 4, and then comma, comma. Okay, there's, okay, so there's a thing that's, I feel like that's more with rough, and it's more with on the Python side, where I would have to add a trailing comma in order to prevent the formatter from, because the formatting in this case, it's multiple things, stuff like um, taking a really long line and making it into this kind of thing where, you know, there's multiple lines and stuff, and a lot of times you would have to use a trailing comma in order to make that happen, in order to get the formatter to do that. I had to do that with rough for Python, because especially when doing data science stuff, I would create like lists, and each item of the list is like a separate line. But then when I hit save, unless there's a trailing comma, when I hit save, the formatter just squashes everything into one line. And in the formatter, there's a setting that you can do which says that, hey, if after formatting, the line would end up being X number of characters long, then don't squash it. Instead, just let it be um, whatever this version is called. Let it be. I'm not able to think of the word, but like let it be like this. Yeah. Let me. Okay. What if I do this? Yeah. In this case, I don't remember if the Rust formatter has that or not. Another thing that it does is add spaces. If you haven't added spaces, let me see if I can demonstrate that here. So I'm going to remove the spaces over here. Okay, in this case, it didn't add it. I'm not sure how to demonstrate it. I, dude, I've seen that happen. I'm not sure how to demonstrate the thing. It looks silly now that I'm not able to demonstrate it, but I've seen, maybe I'm confusing between rough and Rust FMT. But yeah, the formatter, it does do a couple of things. Hold on, let me see what Gemini says that it does. Okay, the formatter, Rust FMT. Neither Rust Analyzer nor Clippy is technically the formatter. That job belongs to a tool called Rust FMT. Its role, it enforces a consistent coding style like spaces. Okay, spaces are a part of that. Indentation, brace placement. How it works. When you trigger a format like so and so, your LSP sends a command to Rust FMT to clean up the file and then proceeds and then updates your buffer. Right. Okay. So I wasn't just imagining things with the save thing. Um, Also, I remember putting this at the bottom, but for some reason it came it came to the top. Okay, let's get rid of this so we don't see the error. You're joking. There was an error, that's why it wasn't doing its job. And now you can see what it did here. Okay, so let me just recreate the thing for it to, do its job again. Maybe I might be able to maybe I might be able to demonstrate the um, what do you call this? The squashing thing. Okay, so remove that, and that. Look at that. When you save, it has certain rules, certain formatting, a certain like coding style that it tries to apply to your code. And that includes indentations and spaces and stuff like that. Let me see if the trailing comma thing works here. It doesn't work in this case, but to be fair, this is a very long list already. It does squash it here, and it removes, in this case, it actually removes the trailing comma if I try to add it. Let's do that, and that, and that, and that, and it squashes it. Let's do undo and try this. Yeah, no, it doesn't respect the trailing comma. That's a rough thing. Anyways, let's carry on with our code. Where was I? All right, next, render the app as a widget. That comes in draw. All right. Okay. Frame.render widget, self, and frame.area. All right. The closure anonymous method passed to the terminal.draw method must render the entire UI. You should only call the draw method once for each pass through your application's main loop. See the FAQ for more information. I feel like I'm going to be exploring this bit a little more, just trying to redo the boilerplate code myself, uh, just so I can get a hang of, actually doing TUIs in Ratatouille. Okay, testing the UI so and so. Okay. All right. You should see this interactivity. The application needs to accept events that come from the user via the standard input. The only events this application needs to worry about are key events. For information on other available events, see the cross-term events module, docs. Okay. These include window resize and focus, pace, and mouse events. In more advanced applications, events might come from the system over the network or from other parts of the application. Okay, handle events. The handle events method that you defined earlier is where the app will wait for and handle any events that are provided to it from cross-term. Update the handle events method that you defined earlier. Okay, so we do match event read, then we do event key event. Wait, what is this? There's an if condition in here. I didn't know you could add if conditions in, or maybe I learned it while learning, the basics of match patterns. Maybe I did learn it and I forgot that this was a possibility, because I would have definitely put this if thing within the code block that's for event key. But this is interesting. If event key dot kind equals key event kind, press. All right, then we do self, handle events, key event. And finally, we give this wildcard thing or discard thing, I think it's called. Discard, I guess. And we return OK. All right, the event read function blocks until there is an event. If your application needs to perform other tasks than just the UI, then you should check whether there's a pending event by calling event poll with a timeout that is reasonable for your application. More about this will be covered in a future chapter. Handle keyboard events. Okay, your counter app will update the state of the app structs fields based on the key that was pressed. The keyboard event has two fields of interest to this app, kind and code. Kind. It's important to check that this equals press, as otherwise your application may see duplicate events for key down, key repeat, and key up. Then code, the key code representing which specific key that was pressed. Okay. Add a handle key event method to app to handle the key events. Right. KFN handle key event. Okay. Key event. All right, then match key event dot code key code char q. Then we do self dot exit. Did I define an exit method? Is there an exit method? I don't think there's an exit method. Hold on. That's interesting. You can just toggle the thing by calling. Wait, no, how does that work? Is that really a thing? Hold up. Where the I need to open up a different project to do this. Okay. Let's do I don't know, some rust proj 01 and then cd into some rust proj 01 cargo init. Open this up. All right, now in here, okay, let's create a struct, some struct 01. Let's also do derive debug so I can print out the values. And no, how is it doing? Wait a second. Are the methods going to be implemented later on? Fuck me, dude. Okay, dude, fuck off. Hold on, let me, yeah, okay. What was the name of the thing? Ratatouille, yeah. Ratatouille proj. Wait, how many Ratatouille projects are there? Wait, back up. Oh, that's why. Yeah, I'm in the wrong one. I'm supposed to be in counter. Yeah. Where was I? Over here? Okay, before I do this, I should implement these methods because otherwise I'm going to be, you know what? No, it doesn't matter. It's a small thing. It's not like the lack of intelligence is causing a major issue. Okay, left, then we do self dot decrement underscore counter, then we do key code right, self dot increment counter, And finally, we do our discard pattern. Next, add some methods to handle updating the application state. It's usually a good idea to define these on the app rather than just in the match statement, as it gives you an easy way to unit test the application's behavior separately to the events. Okay, right. All right. Exit, mute, self dot exit equals true. Is there no way to toggle this? Like, what happens if can I do this? Would this work? It's not throwing an error, so I'm guessing yeah, I'm guessing it works. Increment counter, mutable self dot it's just counter, right? Plus equals 1. Then we copy this entire thing, and here we want to do decrement counter and do -1. Caution: normally your application should avoid panicking, but we are leaving an overflow bug in here so we can show how to handle errors in the next section. A real app might use saturating sub or saturating add to avoid panics like this. Why is it going to panic? How? Okay, how is it? Oh, so okay, I knew why it's going to panic, because okay, it's an unsigned byte, meaning it can only go up to where's app? Yeah, it's an unsigned byte, meaning it can only go up to 255 in value. But I was concerned because like I'm not planning on hitting the key that many times. So I was like, why is that going to happen? But yeah, it can happen, and then the program is going to panic. Okay, testing keyboard events. Oh, good. They have something for testing this as well. I need to look into the testing thing. I think that's covered in the conversation here. I actually, you guys won't see it because I don't. Just a second. Oh my God. I am so glad. This is crazy. I completely forgot about this thing. Just a second here. I'm not sure what this is. What's being captured here? Oh, it was on a bit of a delay. Right. So have I just not been using this at all? I have not been using this. The window, you guys have not seen any of this. That's crazy. Well, I mean, it's not that bad because fortunately, I what do you call it? Yeah, it's not that bad because fortunately the only thing that I ran was that Hello World application. And Again, fortunately, the coding that I was doing, it's being captured on a different machine, and I made sure at least that was being captured. This actually needs to be attached to a different session, so it's going to be captured. Now, give me a second while I get out of this and okay, so what was this supposed to go into? Was it Stream Laptop? I don't remember if it was Stream. Wait, no, I have it here, right? Temp Rust Learning. That's what I'm looking at. Temp Rust. Is it Temp Rust Learning? No, it's Stream Laptop. Why did I do that then? It's Stream Laptop. I'm confused about this because you know what? I might be wrong about this. I think you guys were seeing it. Yeah, hold up. Just to confirm this, I'm gonna do cargo. Actually, let's go to the other Ratatouille uh, project. What was the? My God, Ratatouille. Fuck off, dude. Ratatouille project. Cargo run. Okay, is this showing up? We are still on BRB. Okay, it's showing up. What if I quit? Just a second. Let me see that pop up. Okay, so I might have been wrong about this. Maybe you guys saw the previous stuff as well. In case you didn't see it, this is what it looks like. This was the simple Hello World application. Um, okay, Ratatouille counter. All right. Um, Now, what was I doing here? We were handling this. Oh, yeah, I was looking into temp Rust learning. Now, give me a second here while I scroll back up to see all the chapters. So, in the chapters, we have traits and then lifetimes, closures and iterators, smart pointers, concurrency, unsafe Rust, advanced features. It doesn't, okay, it does mention testing best practices. It doesn't mention testing itself, which is interesting. I might have to look into the testing thing myself. But yeah, okay. Hold on. We have been streaming for 2 hours now. And the good news is I can still go for another hour if I want. And I kind of want to go for another hour. But because I've been sitting for so long, I do need to take a short break. Let me just get up and walk around and go piss and um, hydrate again as well. Yeah, I'll be back in a couple of minutes. We're gonna switch to BRB. In fact, now that what am I saying? Yeah, now that what was I saying? Yeah, now that I'm going to be getting into Nano, I feel like I might be able to come up with a nice, interesting BRB screen. So I can just have that application open, and then whenever I need to go BRB, I can, switch to that, switch the scene to that, and have that be captured, and I can have like each time I can have different types of animations. That should be an interesting project to work on, and that'll be some good nano practice as well. But yeah, I'm gonna take a short break for a couple of minutes, and I will be back soon. All right, I am back. Um, yeah, hold on. I'm curious about something, so I'm just gonna, you know what? I'm gonna ask Gemini about this. Hey, so I'm curious about something. Wait, Gemini has this other option, thinking, and then there's also a fast thing. You know what? Okay, we'll go with thinking. By the way, there's a sort of LM Studio kind of like, I'm not sure what to call it. It's it's a sort of LM Studio like project that I have in mind that I want to create using Ratatouille and of course a bunch of other uh, deep learning related frameworks. Um, one one of the main goals that it's meant to accomplish is at the very least one, but multiple, but if possible, then multiple models could be included. At the very least, it should allow you to have a code assist type of conversation with an LLM locally. So you're going to be running the model locally instead of in the cloud. And I'm going to start with one model, but I'll try my best to build this system to allow you to sort of plug and play. I'll have to see how to go about doing that. The entire system is going to be in Rust, so I'm also going to have to see how to go about, adding functionality for these models through Rust. Actually, I was planning on using what do you call it? Transformers. I was planning on using Hugging Face Transformers models, though the Rust equivalent of that, not exactly equivalent, but like somewhat feature complete equivalent in Rust is Candle, which is also made by the Hugging Face developers. And they have added functionality for a bunch of different models, a bunch of the very famous models that are currently supported by the Transformers library. So I could start with those, and that should make it a little bit easier to sort of plug and play, to sort of uh, make using models into like a plug and play kind of situation. I am, I do have like an idea of how I would go about allowing another model to be used, but then I'll also have to see what kind of functionality that model needs to be able to handle. Because when we are talking about code assist, I kind of I kind of want to also add functionality. I definitely won't be able to make something that's on par with Gemini CLI because that's, well, Gemini CLI. Um, I'll have to see to what extent I'm able to use these models. I'll also have to see if it's, specific models that I have to use, or as in models that are built for specific purposes, or would I be better off using a multimodal model? Um, but yeah, I do want to work on a project, and I do have some ideas for how I want to go about doing this. I do want to make it like customizable, at least in terms of which model you want to use. So if you have a better model uh, that you feel can be used in this case, I do want to add in functionality to allow you to use that better model. At the very least, um, I want you to be able to customize. I want you to be able to code in functionality to be able to use that model. In which case, you would need to recompile the application yourself, or I could allow people to write Lua code to create that functionality. I could do that. I could do that. That should be that should be that should be that should be interesting to explore. Though, I mean, okay, the Lua thing would be interesting if there are all that many extra that need to be added. Alternatively, anytime something new pops up, I could just add the functionality manually. Um, and anytime somebody, so like the way I want to create this framework is I want it to be extendable or extensible. Extendable. Let's say extendable. I want it to be extendable. Um, and so the initial support for an LLM, I'm thinking of making it such that like I'll create traits and then I'll define a type that implements those traits, and this type represents that LLM. So any any LLM that you are trying to use, it has to be implemented as this type. And so there's going to be, various traits definer, or maybe just one trait with various functions and properties and stuff defined. And you have to you have to define the functionality yourself for how things are going to be handled. But yeah, yeah. Because the thing is, various LLMs, they tend to have their own ways of giving output. It's not always the exact same structure. Like they all might be giving out. I mean, okay, to be fair, yeah, there are times where they also give out, images or audio or something like that. So I would need to look into ways to allow for a bunch of those different types of output. And logic would need to be defined for handling those situations. But this should be an interesting project. And I don't really care much for GUI. I'm mainly doing this on the terminal, and more importantly, I'm mainly doing this for myself. Like I'm doing this because I need this kind of a tool. Um, and because I'm doing this for myself, and because I use a lot of like older machines, so I definitely won't be using something that is I definitely won't be using an LLM that's like super heavy or resource intensive. I want something that can run decently on the CPU and run well on the GPU. But yeah, okay. What was I? Oh, yeah. Hey, so I'm curious about something. Um, I've been coding for 10 plus years, and in this time, I've barely ever touched the concept of testing. I looked into it a tiny bit through C Sharp, but never really went too deep into it. These days, I'm deep into Rust, and I've noticed there's testing support out of the box. Um, Help me understand this testing thing. And is testing in Rust really that simple? Also, is testing a vast subject that I'll have to spend a bunch of time learning, or can I pick it up real quick? Okay, it's actually more common than you'd think for experienced developers to skip formal testing, especially if you've spent a lot of time in environments where the focus was on rapid prototyping or manual verification. That is true. That is true. And that was also one of the reasons why when I did finally do research on it, I didn't feel the need to look further into it, because when I found out, because like unit tests allow you to create automated tests that you would otherwise be doing manually. So then anytime you make a change to your code, anytime you change anything within your code, you can run like an entire set of tests. And if anything fails in those tests, then you can be like, okay, so if I let this change go through, something's going to break. So I need to change this code again to make sure that these changes that have been made, they don't break any systems. So it becomes really important when you have a lot of like complex, sophisticated systems where you can't really keep track of every single thing. And there's a chance that you might forget that there's, a certain specific thing going on with a certain system. And so when you create a new system or a new feature, and you add a bunch of functionality through that, then that might break something in some other system or in some other part of the program. So that's why you can have these sort of automated tests running. And once you've made your once you've designed your logic, once you've created the code, you can then run these tests to make sure that nothing is breaking, and then you can be satisfied that, yeah, this change, it works with all of the other systems. It plays nice with all of the other systems. Okay. Since you're deep into Rust now, you've likely noticed that the community has a bit of an obsession with correctness. In Rust, testing is just an extra. It's a core part of the work. Oh, it isn't. Okay. In Rust, testing isn't just an extra, it's a core part of the workflow. Okay. Why even bother with testing? Think of testing as codified confidence. When you have 10 plus years of coding in your head, you can usually predict how a change will affect the system. But as projects grow, that mental model eventually fails. Regression testing. You fix a bug. 6 months later, you refactor that module. A test ensures that you don't accidentally break the same bug. You don't accidentally bring the same bug back to life. Fearless refactoring. This is a big one. If you have a solid test suite, you can rip out the guts of a function and rewrite it for performance, knowing instantly if you broke the output. Then documentation tests show other developers or future you exactly how a piece of intended how a piece of code is intended to be used. The testing pyramid. Most developers follow a hierarchy of tests for to balance speed and coverage. Unit tests, small, fast tests focusing on a single function or module. Integration tests, testing how different modules work together. End to end, testing the entire workflow from the user's perspective. I've only ever looked into unit tests. I didn't even know that the other two existed. Okay, is testing in Rust really that simple? Yes, compared to C Sharp or Java, where you often need to pick a framework like NUnit or XUnit, I had to I had to look into NUnit, then configure runners and set up project structures. Rust's approach is a breath of fresh air. The test attribute. In Rust, you don't need a separate project for unit tests. You can write them right at the bottom of your source file. Okay. All right. So it's showing some examples here. Okay, documentation. Doc tests. This is a Rust superpower. You can write the example code in your Markdown documentation comments. You can write example code in your, oh God, don't do that. My God, why would you do that? Okay. All right. Yeah, sorry about that. I'm watching Ariel's stream and she brought up an animation and there was music playing in that and it turned out to be a tiny bit loud. Anyways, this is a Rust superpower. You can write example code in your Markdown documentation comments and cargo test will actually run that code to make sure the examples stay up to date. Then the compiler is your first test. Because Rust's type system is so strict, you don't need to write tests for things like what if this is null, or what if this is the wrong type. The compiler handles that. You only test the logic. Is this a vast subject? Testing is a shallow entry, deep exit subject. That's an interesting way to put it. The basics, 1 to 2 hours. You can learn test, assert, and how to run cargo tests in an afternoon. This gets you 80% of the value. Okay, so I've seen test. I've also seen the assert thing. Where I've seen assert is kind of what showed me the power of testing. It's in the Rustlings course. Because in the Rustlings course, or well, the Rustlings, I don't know what to call it, in the Rustlings application, in the Rustlings framework, the idea is that you open up this file that contains code and it contains broken code. So, code where there is some issue that needs to be fixed, that needs to be solved. So, there's going to be comments and there's also going to be some information within the Rustlings program for that specific exercise. And you have to basically just solve it, right? You make your change and then you hit save. When you hit save, there's a bunch of code that's within that same file itself. It's not like hidden away somewhere. It's within that file. There's a bunch of assert statements that that have to evaluate to true or whatever their conditions are. Those conditions have to be met. Um, Only then will you successfully complete that exercise. So they actually use testing. Actually, now that we are talking about this thing, I do want to see what Gemini thinks about what I was thinking about a while back. Um, of like when the Rust ecosystem was designed, or over time, how the Rust ecosystem has evolved, it kind of seems like they built it to sort of overcome the frustrations that they faced in various other languages. Um, and so you can kind of see results of that. So I kind of want Gemini to talk about that a little bit and get Gemini's input or opinion on that. Because I know what I'm talking about, but like there's still a lot within that subject that I don't know about it. So getting Gemini to talk about it is gonna teach me more about it. Okay, so the first type of well, I was reading the thing about like, is unit testing or is testing a vast subject? The basics, you can pick it up quick, and that's like 80% of it. Then intermediate, a few days, learning how to mock, simulating a database or a web API. Okay, so your tests don't actually try to hit the internet. Just a second. Just a second. There's a couple of things that I'm checking here. Why is this so slow, dude? Okay, all right, that's fine. I think there's a new. Oh shit, VR chat. VR chat new open beta. That's actually from a week ago. They um they added the, what do you call it, third person feature. Well, it's an open beta. They didn't add it yet, but yeah, VR chat, for at least for desktop, for PC, it's getting a third person update. Okay, then what else? There's this thing, and then there's the, oh, I think the capstone project thing for the Gen AI course, not Gen AI, for the AI agents course. I think that is, I think that has an update. Yes, it does. What's going on here? Let's just take a look. We're excited to celebrate the top 12 winners of the Agents Intensive Capstone Project. Hell yeah. Okay, and then we have this. And we also have thing from Rust. Give me a second. I think this was, yeah, I think this was it. Okay. All right. Great. Awesome. Okay, then the deep end. Concepts like property-based testing, where the library generates thousands of random inputs to try and break your code, or test-driven development. Okay, so these are more advanced concepts. Can you pick it up quick? Absolutely. Since you already know the logic of coding, you aren't learning how to code again, you're just learning how to verify it. In Rust, the friction is so low that it usually becomes second nature within a week of use. Would you like me to show you how to set up a small integration test? No, that's fine. Um, no, that's fine. Um, However, I would like to talk about something else. Rather, I would like you to talk about something else. I've noticed that in Rust, there are a bunch of features, design decisions, etc., that make me think the Rust language and even its ecosystem were designed to address various shortcomings and frustrations people had or people faced. Let's say shortcomings, difficulties, and frustrations people faced in other languages. Let's see what Gemini says about that. In the meantime, let me hydrate. Give me a second. Okay, you've hit the nail on the head. Rust is often described as a postmodern language because it because it arrived relatively late, stable 1.0 in 2015. Its creators had the luxury of looking at 40 years of pain points in C sharp, no, in C++, Java, Python, and C sharp, and saying, how do we stop people from suffering through this? Here's a breakdown of the specific frustrations Rust was designed to kill. The billion-dollar mistake, null pointers. In C sharp or Java, any object reference can be null. If you forget to check for it, the program crashes at runtime. The frustration, searching through stack traces to find which variable was null. The Rust fix, Rust doesn't have null. It has the option T enum. If a value can be missing, the compiler forces you to handle the none case. You can't even access the value until you've explicitly checked if it exists. The memory management tug of war. Before Rust, you usually had to choose between two evils: manual memory management, which was in C, C++, or garbage collection, which is in C Sharp, Java, and Go. Manual memory management, blistering speed, but you'll eventually have a memory leak or a use after free bug that causes a security vulnerability. And in garbage collection, there's safety and ease of use, but at the cost of stop the world pauses. Yep. There's a lot of C sharp developers are, especially Unity, especially Unity developers are um, very familiar, very very much familiar with that concept. At the cost of stop the world pauses, where the GC cleans up memory, hurting performance. The Rust fix, ownership and borrowing. Rust uses a system of rules um, that the compiler checks at build time. It knows exactly when a variable goes out of scope and inserts the free command for you. You get the speed of C++ with the safety of a garbage collector. Then, fearful concurrency, data races. Writing multi-threaded code in most languages is terrifying. Two threads try to change the same variable at the same time, and you get a data race, a bug that is nearly impossible to reproduce because it depends on exact timing. The frustration, spending weeks debugging a crash that only happens once every 1,000 runs. That is holy shit. That is crazy. Nah, that is crazy. Without like automated tests, that would be a nightmare. That would be an insane dude. Holy shit. Um, the Rust fix, the send and sync traits. Rust's compiler literally won't let you compile code that that allows two threads to write to the same memory unsafely. It turns concurrency bugs into compiler errors. This is why the community calls it fearless concurrency. Then, dependency hell and tooling. If you've tried to build a 10-year-old C++ project, you know the nightmare of missing DLL files. Missing DLL files, you know the nightmare of missing DLL files, incompatible makefile versions, or broken header paths. The frustration. Um, Spending the first 4 hours of a new job just trying to get the project to compile on your machine. The Rust fix, cargo. Cargo decides that that a package manager, cargo decide, no, not cargo, Rust. Rust decided that a package manager shouldn't be an afterthought. Cargo handles building, dependencies, testing, and documentation out of the box. If a project has a cargo toml file, you can almost guarantee it will build with one command, cargo build. Then, error handling, exceptions versus values. In C Sharp, an exception can be thrown from almost anywhere. You don't always know which functions might crash your program unless you read the entire source code. The frustration, a production crash because a library threw an internal server exception you didn't know existed. The Rust fix, the result type in Rust. Um, Errors are just values. No, the result type. In Rust, errors are just values. A function signature tells you exactly what could go wrong. Then, modern expressiveness. Languages like C are simple but verbose. Languages like C are simple but verbose. Languages like C++ are powerful but incredibly complex. Rust tried to find a middle ground by adopting features from functional programming, like OCaml and Haskell. Pattern matching, much more powerful than a switch statement. Immutability by default. Variables don't change unless you explicitly make them mark them with mute. This makes code much easier to reason about. Okay. Rust is essentially a greatest hits album of programming language theory packed into a tool designed for the real world. I like that analogy. Since you've been using it for a bit, is there a specific feature you've encountered that felt, no, okay, that's fine. That's fine. Thank you for the information. Awesome. Now, where was I? Okay, so this test thing got me kind of distracted. I think I might actually look into this off stream. But before that, okay, Rust test. Unit testing, Rust examples, how to write tests. Okay, testing, test and this, test and that. What else comes under unit? What else comes under testing in general? Documentation testing, integration testing, and dev dependencies. Okay, they have a good amount of information here. Writing tests. What comes under this? Controlling how tests are run in test organization. Okay, okay. All right. Yeah, so I'm going to keep this open and then later on I can come and look at it. And for now we can continue this. Okay. All right. Running the app. Make sure you save all the files and that the imports listed above are still at the top of the file. Some editors remove unused. Yeah, okay. And then cargo run and we should be seeing this. Press left and right and this and that and this and that. Note what happens when you, oh, okay. So earlier I was mentioning that I was kind of confused about how they thought we were going to hit the limit. I was looking at the upper limit. I forgot that this is an unsigned byte. So it doesn't have anything below 0. It's 0 to 255 because it's an unsigned byte. If it was a sine byte, it would be negative 127 to positive 126 or negative 126 to positive 127. Um, yeah, yeah. So in this case, the way that you hit that exception or that panic is by trying to go below zero. Um, you can reset to fix your console. You can run reset to fix your console. On a Windows console, you may need to restart the console to clear the problem. We'll properly handle this in the next section of the tutorial, which is error handling. Conclusion: by understanding the structure and components used in this simple counter application, you are set up to explore crafting um, more intricate terminal-based interfaces using Ratatui. Okay, so let's run this. We have an error. Yeah, okay. I think one of these. Hold on. Oh, did I not save it? No, I did save it. Okay, where is that showing an error? What line did it say? Also, I think there's multiple. Could not compile. No, there's right. This method takes 0 arguments, but 1 was given. Does it take 0 arguments? Oh, I messed up somewhere here. I think, right, where is it pointing? Line 48 and, no, line 47 and 49. Um, Hold up. Line for, oh, there's the errors. You know what I should do? Okay. Diagnostics would be that, but then that's not showing up anywhere there. There was another thing. Okay, D is for line diagnostics, right? Hold on. What does launching Mason from here do? It literally just launches Mason. Okay. Um, was it from here maybe? This might be it. Yeah, yeah, this might be it. And this gives us, okay, this is great. This is great. This gives us the line. I should keep this in mind. Let's close this and um this would give it for the entire project, wouldn't it? Yeah, so this is for the entire project, and then this specific one is for this specific what do you call it? Yeah. Okay, so also initially it was kind of it was a little bit annoying that um it's opening up this window, but it's not showing. What am I trying to say? It's opening up this window, but it's not shifting the focus here so I can close the window. But then it makes sense because how this is meant to be working is as you're scrolling, it's going to highlight like if you are on that line, then it's going to highlight that specific line. And I'm guessing in cases where it's this, where there's multiple diagnostics on one line, it probably goes for the top one or the bottom one. I'm not sure which one it chooses. Hold on, I'm not sure it's using either of. these. Oh, it is. So in this case, it's using the last one. What about here? Yeah, in this case, also it's using the last one. Uh, is there any way to? Yeah, no, it's not. So it's only going to highlight the one that's. If it's one, then it's only going to highlight that one. And if it's multiple, it's going to highlight the very last one. Either way, we can close this and let me just look at this. Match arms have incompatible types. Backup. What's the issue here? Am I supposed to be doing key event? I'm supposed to be doing key event. Yeah, I think that's what it is. Handle key event. Isn't that what the code here was? Hold on. Handle keyboard event, handle key event. Because yeah, because handle key event does take something. Yeah, there it is. That's what the problem was. And just like that, I think, yep, all our errors are gone. Awesome. Great. Let's try running it again. There's our application. We can increment, we can decrement, and if we go there, then the program panics. So thread main panicked at so-and-so, attempt to subtract with overflow. Yep, makes sense. Makes sense. All right. Okay. Uh, right. How big is that error handling thing? Because after today's stream, I'm definitely going to sit and practice this a little bit because there's a bunch of like boilerplate code here that I want to look into. Maybe not necessarily, this exact same code. Um, I want to build my own thing and understand the various components here. For example, um, the widget render method or implementing the render method for widget. And then implementing these various methods for the app struct, and then also implementing the app struct itself and main. Okay, now that I'm looking at it, it does seem, because the thing is, I want to get to a point where I'm not trying to memorize shit. I'm trying to implement things because they need to be implemented. And I'm trying to make it so I can kind of remember to implement these things because they have certain utility, they have certain use. Man, I think my voice is kind of getting tired because it's starting to crack a lot more. To be fair, almost almost dropped my phone. To be fair, I was kind of having trouble speaking from almost the beginning of the stream. Um, what was I saying? Sorry, zoned out. Okay. Yeah, I wanna get to a point where I remember that okay, this is our app. Within app, there's supposed to be this thing, this function called run needs to be implemented. And within this function, we're going to call terminal.draw, and we'll also handle events, which they mention that you should be polling for events if you don't want to block the app. So I should look into that as well. So then we have draw, terminal.draw, and oh, within terminal.draw. So terminal is what? What are we using terminal from exactly? Where is, hold on. Oh, terminal terminal is from here, and this terminal is the default terminal. So a type alias for the default terminal type. This is the terminal using the cross-term backend, which writes to standard out. Um, this is a reasonable default for most applications to use a different backend or output stream. Instead, use terminal and a backend of your choice directly. Okay. I might have to do this when I start going into um, doing Ratatouille stuff on the ESP32. Okay, all right. Let's move over to error handling. Counter app error handling. This tutorial is outdated since Ratatouille so-and-so. We introduced the Ratatouille init and restore methods in so-and-so, which automatically set up panic hooks that removes the need for the TUI module here. We will update the tutorial soon. Full source code is available at so-and-so. In the previous section, you created a basic counter app that responds to the user pressing the left and right arrow keys to control the value of a counter. This tutorial will start with that code and add error and panic handling. All right. A quick reminder to where we left off in the basic app. The problem, hold on. The problem. The app you built in the previous section has an intentional error that is caused has an intentional error in that causes the app to panic when the user presses the left arrow key when the counter is already at 0. When this happens, the main function does not have a chance to restore the terminal state before it exits. Okay? The application's default panic handler runs and the displays the details messed up. This is because raw mode stops the terminal from interpreting new lines in the usual way. The shell prompt is also rendered at the wrong place. I didn't even pay attention to that. Hold on, let's look at that again. Okay, you know what? It didn't break up for me, but I'm wondering if that's because I'm running this in Tmux. Like, I wonder if somehow that might be handling the issue. So I think maybe if I was not running this in Tmux, I can test this out later on my other machine. Um, so I'll be running it directly on that machine as opposed to, you know, typing in the code, typing in the Rust code from that machine into a project that's running on this machine, which is, yeah. Because in that case, then I won't be using tmux. In that case, it'll be running like directly on that machine. Okay. To recover from this, on a Mac OS or Linux console, run the reset command. On a Windows console, you may need to restart the console. Oh man, I'm yawning like crazy. Okay, there are two ways to handle. There are two ways that a Rust application can fail. The Rust book chapter on error handling explains this in better detail. Rust groups errors into two main categories: recoverable and unrecoverable errors. For a recoverable error, such as file not found, we most likely just want to report the problem to the user and return and retry the operation. Unrecoverable errors are always symptoms of bugs, like trying to access a location beyond the end of an array, and so we want to immediately stop the program. Okay. One approach that makes it easy to show unhandled errors is to use the color IR crate to augment the error reporting hooks. In a Rust application that's running on the alternate screen in raw mode, it's important to restore the terminal before displaying these errors to the user. Add color IR, okay. Update the main oh yeah, this is a bare bones project. I forgot about that. I think I'm gonna need to. Yeah, I think I'm gonna need to restart the project. Okay, so we'll do cargo add color IR. Okay, this is done. Then cargo build. All right, that is done. Now we open this up and we are good to go. Give me a second. Okay, so sorry about that. So update the main function's return value to color IR result and call the color IR function. Oh, color IR install function. We can also add an error message. You know what? Hold on. In Rust, I have heard about color IR being mentioned. I had a conversation with Gemini about this before, and what I got from it was that color IR does a better job of displaying errors than apparently Rust itself. In what way? I'm not sure. Um, hey, so I've been learning how to use Ratatui. I noticed it uses color IR. Upon doing a bit of research, I learned that apparently it does a better job of displaying errors. Oh, okay. A better job of displaying errors. I still don't fully understand what it is and what it does and how it does a better job of displaying errors. Okay, the fact that you're looking at color IR while working with Ratatouille is perfect timing. In the TUI world, error handling isn't just about printing a message, it's about saving your terminal session. Here's the breakdown of what color IR is, why why it exists, and why the Ratatouille community is so fond of it. Sorry, man, I'm gonna need to end soon. Holy shit, I'm getting like crazy sleepy. Okay, the lineage. Anyhow is another one that I've heard of when it comes to like error handling. Okay, anyhow, IR and color IR. To understand color IR, you have to see where it came from. Anyhow, the industry standard for application level error handling, it gives you a generic result so you don't have to define custom error types for everything. IR is a fork of anyhow that decided errors should have more than just a string. It allows for report handlers, plugins that change how the error is captured and displayed. Then color IR, the most popular report handler for IR, it's the visual and contextual it's the visual and contextual engine. Okay, what does it actually do? If a standard Rust program panics, you get a wall of white text and a messy bracket. Color IO transforms this text into a structured, readable report. Key features: one, key feature one, the visual polish. It uses colors to highlight the most important part of an error. Okay, yeah, it uses colors to highlight the most important parts of an error. Instead of hunting for the file name and line number in a sea of text, they are highlighted in bold colors. Key feature 2, suggestions and sections. This is the killer feature. You can attach suggestions or custom sections um, to your errors. If your app fails because a config file is missing, you can bake a suggestion into the error. That's crazy. I didn't know about that. Okay, okay. When this error prints, it won't just say failed to load config. It will have a dedicated colored box at the bottom telling the user exactly how to fix it. Uh, Key feature 3, filtered backtraces. Standard Rust backtraces include every single internal function call, including the Rust compiler's own startup code. Um, Color IR filters out the noise and only shows the frames relevant to your code, making debugging 10 times faster. Why it's a must-have for Ratatouille. In a Ratatouille app, your terminal is in raw mode. This means the application has taken control of the screen, disabling line buffering and stopped the cursor from blinking. Wait, where was I here? Oh, okay. The problem, if your app crashes or panics while in raw mode, your terminal stays in that broken state. You'll be back at your prompt, but your typing will look invisible. Enter won't work right, and your screen will be a mess. You'd usually have to wait for the you'd usually have to type the reset command blindly to fix it. The color IR solution, when you call colorir.install at start at the start of a Ratatouille app, it sets up a panic hook. The app crashes. ColorIR catches the crash. It automatically executes the code to restore the terminal. Exit raw code, show the cursor. Exit raw mode, show the cursor, etc. Only then does it print the beautiful colored colored error report. Without it, your users and you during development are left with a broken terminal every time a bug occurs. All right. Okay. Right. Oh, all right. So give me a second here. Okay. Uh, where is it? Here. Okay, there's someone learning Duolingo. There's someone doing co-working and studying. Okay, okay, okay. Just a second. Okay, you know what? There is somebody here who is doing. I hope their thing is not follower only or. Yeah, okay. They are doing rigging. Rigging for head turn. I think they're a live 2D artist. Yeah, I think so. I think so. So, yeah. You know what? We're gonna go there. I hope their raid settings allow for one person raids. Their name is Mander Monster. Yeah, okay. We can go to their stream. So that's going to be it for today's stream. I wish I could go longer, but like I'm getting really sleepy and like I kind of dozed off multiple times already while trying to read the stuff. So I'm just not going to be grasping anything at this point. If I keep trying to if I keep trying to force it, it's just not going to work. The funny thing is, as soon as I finish the stream, I'm gonna feel fresh again. I have no idea like what's up with that, but yeah, pretty soon I'm gonna need to go to sleep. But yeah, that's gonna be it for today's stream. Um, I'm hopefully I'm gonna stream again tomorrow, and we're gonna keep the streak going. Uh, Today is the well, right now is the 19th of December. I'm hoping all the way up until New Year's, I'll be streaming every single day. I hope so. I hope that happens. On New Year's Day, I don't know. Actually, the day before New Year, so like around 12 o'clock kind of thing. I don't know if I will be streaming. I'll see. But okay, the raid timer is about to run out. Uh, yeah, I hope you guys have a nice day, and I'll see you all next time. Peace.